check convergence and divergence of the following series. What I'm going to do, I'm going to use comparison test here. We are going to use comparison test. Let us do a little bit of algebra. From algebra and the definition of factorial, what do we know? We know that when we have 0 factorial, it is equal to 1. 1 factorial is equal to 1. 2 factorial is 2. 3 factorial is 3 times 2 times 1. 4 factorial is 3 times 2 times 4. I forgot to add 4. Okay. 4 times 3 times 2 times 1. And in general, n factorial can be written as n times n minus 1, n minus 2, dot, 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 3 times 2 times 1. We have an observation here. When it comes to factorial, you can basically do a little bit of algebra yourself. So, obviously, starting at 2 factorial, which is equal to 2, this guy is more than equals to 2 itself. It's more than equals to 2. 3 factorial is more than equals to 2 times 2 times 1. 4 factorial is more than equals to 2 times 2 times 2 times 1. If you continue this process, you can see that your n factorial is more than equals to 2 times 2 times 2 times dot, 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 2 times 2 times 1. So what is my observation here? My observation is n factorial is more than equals to 2 to power n minus 1 times 1, which is basically 2 to power n minus 1. All right, very good. So why is this helpful? Because if I flip this, 1 divided by n factorial is less than equals to 1 divided by 2 to power n minus 1. Nice and easy. I found something very useful here. Why is that? Why it is useful? Because now I have an less than equals to bn. By comparison test tells me that if I have an less than equals to bn and the summation of bn is convergent, I can indeed conclude that the summation of smaller term an is convergent as well. From algebra, basic algebra, to finding a comparison term for 1 over n factorial. So 1 over n factorial is less than equals to 1 divided by 2 to power n minus 1. So what is this sum on the right-hand side? Well, the sum on the right-hand side is basically a geometric series. The summation of one divided by 2 to power n minus 1 is a geometric series. So what's the ratio? You can rewrite this. You can simplify this as well. This guy is the summation of 1 divided by 2 to the n times 2 to power negative 1. You can flip this and write it on the numerator. You get 2 times the summation of 1 divided by 2 to the n, which can be written as 2 times a half to power n. Let me take this one. 1 over 2 to power n. Let me add the summation notation. so we don't get confused. Two times the summation of a half to power n. But the ratio here is, for this geometric series, the ratio is a half, which is less than 1, all right? Or it is more than -1 as well, to be more official. So the geometric series is convergent. Okay, now applying limit comparison test. Since the series on the right-hand side is convergent, the larger series is convergent, it means that the smaller series must be convergent. So by limit comparison test, since this series is convergent, you can conclude that the series of 1 divided by n factorial is also a convergent series using the comparison test here. So let us recap what we did. Here we are checking the convergence and divergence of the summation of 1 divided by n factorial. N starts from 1, goes to infinity. I'm going to use comparison test. Why? Because I can do algebra easily. From algebra, 0 factorial is 1. 1 factorial is 1. 2 factorial is 2, which is more than equals to 2. 3 factorial is 3 times 2 times 1, which is more than 2 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1, which is obviously more than 2 times 2 times 2 times 1. With the same discussion, you can write n factorial as the multiplication of n times n minus 1 times n minus 2 times the rest of the terms, 3 times 2 times 1. The larger number is going to be more than equals to 2 to power n minus 1 times 1. So you end up with 2 to power n minus 1. So if you flip this, you get 1 over n factorial less than equals to 1 over 2 to power n minus 1. Hey, I found two general terms, 1 over n factorial and the other guy, which is basically the general term of a geometric series. By using comparison test, if I show the larger series is convergent, I can conclude that the smaller series is convergent as well. But larger series is convergent because it's a geometric series. The ratio is a half, which is bounded between -1 and 1. So the series on the right is convergent. It means that the series on the left is also convergent by using the comparison test.